Good day, Mom. I'm Lera Galicia from grade 11 under Sun. The topic is the space before the Big Bang. The universe has not existed forever. It was born around 13.82 billion years ago. Matter, energy, space, and time erupted into being in a fireball called the Big Bang. It expanded, and from the cooling debris, there congealed galaxies, islands of stars of which our Milky Way is one among about 2 trillion. This is the Big Bang theory. In the beginning of the Big Bang, there was the inflationary vacuum. When it doubles its volume, it doubles its energy. When it tripled its volume, it tripled its energy. Banknotes were like this, and you pulled apart a stock, even more would appear. Physicists called inflation the ultimate free lunch. Inflationary vacuum expanded ever faster, but it was a quantum thing, and quantum things are fundamentally unpredictable. Randomly, all over the inflationary vacuum, parts of it decayed into ordinary everyday vacuum. Think of tiny bubbles forming in a vast ocean. In each bubble, the inflationary vacuum disappeared, but its enormous energy had to go somewhere. It went into creating matter and heating it. It went into creating a Big Bang. Our Big Bang universe is merely one such bubble among a possible infinity of other Big Bang universe in the ever-expanding inflationary vacuum. The basic idea that the universe began hot and dense and has been expanded and cooling ever since is incontrovertible, but cosmologists have had to make tweaks to the theory to account for certain observations. First, in the standard Big Bang model, galaxies grow by gravitational pulling in matter. But if this were the only thing going on, it will take much longer than 13.82 billion years for them to form. Astronomers fix this by postulating that the visible stars and galaxies are outweighed by a factor of 6 by invisible dark matter, the extra gravity of which speeds up galaxy formation. The basic Big Bang predicts that the gravitational attraction between the galaxies acts like a web of elastic, slowing cosmic expansion. However, in 1998, astronomers discovered that the universe's expansion is speeding up. They fixed this by postulating the existence of dark energy, which is invisible, fills space, and has repulsive gravity. Final tweak to the basic theory is needed to explain why the universe has the same temperature everywhere. To account for this, astronomers think that the universe early on was smaller than expected, then underwent a super fast expansion in its first split second, an inflation. This was driven by an inflationary vacuum, a high energy version of the vacuum that exists in space today. The twin pillars of modern physics are Einstein's general relativity and quantum theory. The former reigns supreme in the large-scale universe, while the latter orchestrates the small-scale world of atoms and their constituents. They have resisted a merger, which is a problem because in this Big Bang, the universe was small. In earlier, this thinking goes, at some point, our entire universe, all the stars, all the galaxies, all the everything, was the size of a peach and had a temperature of over a quadrillion degrees. Amazingly, this fantastical story holds up to all current observations. Astronomers have done everything from observing the leftover electromagnetic radiation from the young universe to measuring the abundance of the lightest elements and found that they all line up with that the Big Bang predicts. As far as we can tell, this is an accurate portrait of our early universe. But as good as it is, we know that the Big Bang picture is not complete. There is a puzzle piece missing, and that piece in the earliest moment of the universe itself. Words, the complicated and admittedly poorly understood physics of this critical watch may indeed allow for a radically revised view of our time and place in the cosmos. But to fully test this model, we'll have to wait for a new generation of cosmology experiments, so let's wait to break out the parodic campaign. That's the end of our topic. Good day, Mom, and thank you for watching.